Welcome to Chapter 19. We're going to be talking about the heart, and we're going to look at the heart muscles, we'll look at the valves, the blood vessels that nourish the heart. And I want to start out, when you start reading the chapter, it has a little box at the very beginning that says, hey, if you've forgotten what desmosomes are, or gap junctions, or if you don't remember how the sliding filament works, you should go back and review that. So what I did is I went and I found this British lady, and she's talking a little bit about cardiac muscle, so I thought I would let her review desmosomes, gap junctions, and talk about intercalated disc.
There is one other feature of heart muscle cell that we should be able to see as well, and that's where one fibre meets the next one. We can use the term fibre as interchangeable with cell in terms of muscles. Where one meets the other, they interdigitate with a bunch of gap junctions to facilitate the transport of the signal, and desmosomes to join the cells together. So this cluster of gap and desmosome junctions is called an intercalated disc, and so each fibre is knitted to the next one by intercalated discs. And once you've sort of spotted one, you can see a few more. So there's one here, there's one over here, there's another one down here as well. So that's another bit of a giveaway that we are in cardiac muscle.
Here's a higher magnification of what the lady was talking about. If you remember what the striated muscle looks like for the skeletal muscle, the heart muscle is similar in that it has the striations or the stripes, so you can easily see the stripes on the muscle fibers. But you see these places where it looks like they're banded together. So here's this banded together, and that's what she was calling the intercalated disc right there. So the object of the game is when the heart contracts, you want the whole heart to contract. You don't want just this little area or that little area. Now with skeletal muscles, I want my muscles to be able to work independently of each other. So I don't have intercalated disc. So I can wave my hand without wiggling my leg. Or I can kick a soccer ball without scratching my nose. So each of my muscles is under my control for my skeletal muscles. But the heart muscle, I can't have that happening, because if I do, then I'm in fibrillation and the heart's just quivering because it doesn't know which muscle fibers to contract at what time, and then some are relaxing and some are contracting, and it's just a mess. And so you're going to end up having to have paddles to shock the heart and make it stop and then start beating together like it's supposed to. So if you have these gap junctions, these intercalated discs, where each of these are talking to those fibers, and you see here those fibers are talking to these fibers, and if you follow on down, these fibers are talking to these other fibers. And so it's like everyone is talking to everybody. So when the signal goes out to depolarize, it's able to quickly go from muscle fiber to muscle fiber. Another thing that your book likes to do at the very beginning is to tell you the names of some of the important people in the particular area. So they're talking about Aristotle. Everybody's heard of Aristotle, and they're saying, oh my goodness, he was so wrong that he held the knowledge of the heart back for so many years, because everybody kept saying, well, Aristotle said it, it must be right. But then eventually they overthrew all the things. But one of the things that Aristotle said is that the heart helps heat the body. Well, anybody should know that when the blood circulates and goes down into the toes and goes into the fingers, it brings warmth with it. So I don't know why your book says that Aristotle was completely wrong. Now, he thought it was the seat of emotion, because if you're frightened, if somebody scares you, you literally will feel your heart jump, because you get a jolt of adrenaline that rushes through your bloodstream and goes to the heart and causes it to contract suddenly. So you can feel it. So they said that the heart is, or Aristotle said that the heart is the seat of emotion. Well, it definitely reacts to emotion because you have hormones that come out. But one of the things that they never dreamed of in all of these people in the past was that we would be able to take the heart out of someone who passed on and attach it to someone whose heart isn't working correctly. So you can do a heart transplant. And when the person wakes up and is recovering, one of the things that they found, a lot of the people who had a heart transplant have some memories of the person who passed on. Now, one of the things that they do whenever you get a heart transplant, they try very hard that you don't know who you got the heart from. So you don't know if it was a child, a man, a woman. All you know is that the proteins on the outside of the cells of the heart match the closest to the proteins on the outside of your cells so that you don't reject the heart. So the more compatible the heart is, the less likely you are to reject it. But now, how in the world would you have knowledge of the person who died? But they keep finding cases of that over and over again. So my hypothesis is if your nerve cells in your brain are able to retain memories, why can't the nerve cells in your heart also retain memories? So who knows? It could be fake news. It could be real. But maybe Aristotle was on to something. It's important that you guys know about the heart and study this chapter well, because if you're going into the healthcare profession, you're going to be dealing with a lot of people with a lot of heart problems. Right now, it's the #1 killer in the United States. It's the #1 cause of death. And we have come a long way. So we have nitroglycerin to open up your blood vessels and improve your circulation. So a lot of times in TV shows, you see somebody and they fall to the ground and they're clawing at their chest and they're going, my pills, my pills. And they'll go and get one of the pills and put it under their tongue or put it in their mouth. And then they're like, oh, thank you. So that's what they were giving the person. If your heart isn't beating with a normal rhythm, if you have some odd things going on, then we found a drug called digitalis that can help abnormal heart rhythms even out. People who have high blood pressure, so the heart is having to push so hard and there's so much fluid hitting the aorta and continuing on throughout the body that you're actually in danger of popping the blood vessels, then we can give diuretics. We can cause you to pee out the extra fluid so that you lower the pressure in your blood vessels, and you're less likely to have a stroke or a coronary or an aneurysm. One of the interesting things we've learned how to do to save people's lives is do a coronary bypass. So you've probably heard of, oh, so-and-so had a triple bypass or quadruple bypass. So what they do is they go down in your leg and they remove a blood vessel from your leg. And then this is a paradox. This just doesn't make sense. You know, when you very first hear it, you're like, no, that can't be right. Your heart pumps blood. You all know that. You learned that even in first grade. But when you think about how thick the heart is, and we're going to be looking at that soon, but when you think about how thick it is, the blood and the oxygen can't permeate through the whole heart. So it drops down in the chambers inside the heart, but the outside of the heart has to have a source of blood also, or else the tissue will die, it won't get enough oxygen. So all along the outside of your heart, you've got a series of blood vessels. And it's those, the coronary arteries, the coronary blood vessels on the outside of the heart that are trying to nourish the muscle of the heart that get blocked with fat. And you can already see from this picture that there's some fat along the heart there anyway. So in this case, they're going to take a piece of heart vein, artery, remove it, and put this and restore blood flow to the outside of the heart. So a lot of people don't know what bypass surgery is. It doesn't bypass the heart, it bypasses the vessels on the outside of the heart so that you can nourish the heart muscle. So here's a half-minute video that shows them attaching this and doing a coronary bypass operation. All right. Almost look like a fishing worm. All right, there's where they're going in, and they put a stitch on the existing vein, and there they just sew all around the edge of it. Another thing that they can do is they can replace the valves in your heart. So valve replacement, so many things. The whole heart, just the valve, blood vessels on the outside, or different medicines. So we have a number of treatments, but still heart problems are the number one cause of death in the United States. So our next slide says that we need to distinguish between the pulmonary circuit and the systemic circuit of the heart. And then of course we want to know where the heart is, how big it is, the shape of it, and then talk about the pericardium. So that's our goal for the next couple of slides. So if you could imagine the heart is actually two separate things, two halves, and they're connected with a muscle, and it's got a lot of fibrous tissue that separates the two halves of the heart. So the blood in one half of the heart doesn't go into the other half of the heart. So you've got two things going on simultaneously. So I said it's kind of like a three-legged race where you have two people doing two different things, but you've tied their legs together. So in this case, you've got the two halves of the heart that are sharing a septum. They're sharing a wall. So the pulmonary half is going to go to the lungs. Pulmonary means lungs. And systemic is that when that leaves the heart, it's going to go through the aorta and it's going to go through the entire body. So you've got to push hard enough that it's going to leave the heart and go up to the brain, down to the arms, down through the trunk of the body, and all the way to your toes. So the systemic is your whole body except for your lungs. And that's the other half of the heart that sends the blood to and from the lungs. So that's kind of a odd concept, so you need to get your head around that one. All right. So it's important to know that the pulmonary circuit goes from the right side of the heart, and the systemic circuit is the left side of the heart. So keep that in your mind. And I put it in red for you because the systemic blood has been oxygenated. It's already gone to the lungs, it's picked up oxygen, and now it's ready to go to all the tissues in the body. And I did the pulmonary circuit in blue because your blood has dropped off oxygen and it's actually changed colors because it doesn't have the oxygen to change the shape of the molecule. So anyway, this is not something I invented. This is what you'll find that they'll usually show the pulmonary is blue and the systemic is red. So this is the first figure, and they're trying to show you this. So here we are leaving the heart, going to the lungs, coming back, and then going out to the rest of the body. And then the oxygen depleted blood comes back, comes in, goes to the lungs, gets oxygenated, comes back as nice red oxygenated blood, and is pumped throughout the body. So this is kind of a schematic telling you kind of what's going on. So we're going to learn about the plumbing and all kinds of stuff. But so that's what's going on here. Try to tell you that there's two halves of the heart doing two different things. So let's talk a little bit about the plumbing of the heart. So we talked about the left side is the one that sends the oxygenated blood out. Well, first of all, over on the right side, you've got the inferior, which is below, and superior vena cava, and they are going to pour the oxygen poor blood from the rest of the body. So inferior is bringing from below, superior is bringing from the upper part of your body and dumping it into the right side of the heart. Now it's going to dump into the atria, and then it's going to flow down into the ventricle. So it passively flows down in there. And as it fills up and fills up down in the right ventricle, it's getting ready for when the heart contracts, and it's going to push the blood over to the lungs by way of the pulmonary trunk. So coming out of the heart on the right side is the pulmonary trunk, and it branches, and one part of it goes over to the left lung and the other half goes over to the right lung. So blood is going to come in with the inferior and superior vena cava dumping into the right atria and then going down into the right ventricle, and then it will be pushed out to the lungs by way of the pulmonary trunk and then the pulmonary arteries. At the same time this is happening, the pulmonary veins are going to take the oxygenated blood and send it back over to the left side of the heart. So you're going to go from the lungs through the pulmonary veins to the left side of the heart into the atria. You're going to drop down into the left ventricle, and when the heart contracts, blood is sent to the aorta, through the aorta, to the rest of the body. Now what you need to get your head around is this is happening at the same time. The left side doesn't contract and the right side contract. They both contract at the same time. So when the heart squeezes shut and pushes the blood out, on the right side, it's going to shoot through the pulmonary trunk and go over to the lungs. At the same time, the blood is going to be squirted out of the aorta and through to the body. And then when the heart relaxes, then blood is going to start pouring back into the right side of the heart through the inferior and superior vena cava, and blood is going to start pouring into the left atrium through the pulmonary veins. So both halves are working at the same time, but they're doing something completely different with the blood. So maybe pause this recording and stop and think about, okay, what's going on, what's going where? Because you really need to know how the heart is plumbed and know what's going on when we talk about the heartbeat. So where exactly is your heart? Well, it's located between your lungs, but it's tilted towards the left, and the point of the heart is pointed downwards. So that's a little unusual. But when you talk about the apex, like you talk about apex predators, they're at the top of the food chain. And you talk about the apex of a mountain, you're talking about the very, very top of the mountain. But apex doesn't mean top, it means pointed. So I put this little nota bene. It says, nota bene means pay special attention to this. Because when you talk about the apex of the heart, you're not talking about the top of it, you're talking about the bottom. So nota bene. Sometimes you'll see a little NB, and it says pay special attention to that. Now, if you clench your fist, that's how big your heart is. So if you see a little bitty kid clench their fist, that's how big their heart is. If you see a great big old football player clench their fist, that's how big their heart is. So pretty much that's a rule of thumb. Now, when you think about all the blood that's in your body, you're like, wait a minute, I've got like 4 to 6 liters of blood in my body. How am I going to, all right, look at a 2-liter Coke bottle. Can everybody see a 2-liter Coke bottle? And you've got 2 to 3 times that much blood in your body. Now look at your fist. How are you going to push all of that? Well, that's why your heart keeps beating. Because open your fist up just a little bit and see how much fluid you can put in there. Now squeeze it out. It's not a whole lot of blood. Now relax it and squeeze it again. So you're not squirting a whole lot of blood with each heartbeat. So a lot of people are thinking like whole liters of blood are squirting out of the heart, and it actually isn't. So there's a lot of misconceptions about the heart. So hopefully I'll sort you out and get some of those not so confusing for you. So here's another thing that I forgot to mention. 16 ounces make 1 pound. Your heart weighs about 10 ounces. So it's barely 2/3 of a pound. So that's also, I mean, most people think their heart's huge and weighs so much. And because the apex is at the bottom and the heart points towards the left, in order for it to fit between the lungs, there's actually a notch cut in the left lungs. It almost looks like somebody took their fist and just hit the lungs and made like a little indentation there so that the apex of the heart could fit into it. So when we do the lungs, you can easily tell which is the right lung and which is the left lung, no matter how they show you the x-ray or the film that you're looking at, because the left one's the one's got the place notched out for the heart to fit into. So here's a picture from your book that shows you kind of how the heart is oriented. And there's the apex down there. Obviously this is the left lung because you can see the notch that allows the heart to fit in there. And you'll notice both the lungs and the heart are attached to the diaphragm. So the diaphragm is a muscle, but it's also a connective tissue. So it's both a muscle and connective tissue. And your lungs ride up and down on your diaphragm. And so does your heart go up and down on the diaphragm. Now, one of the things that I think is kind of interesting, so this guy named Valsalva decided to name this after himself. And I'm thinking, oh, this is so weird. So if all of you guys could take a second and pretend to have a very vigorous bowel movement. All right, so what do you do when you do that? Well, you take a deep breath. Okay, and then you push down, you bear down actually with the diaphragm. And so one of the things that my students, a lot of times I have students who their job is to work as a EMT, and they ride in ambulances and so on. And they're wanting to go and get a, bigger, better paying job. And so they come back to school. And it's so funny because when I talk about this, the Valsalva, they're like, oh, because a lot of times you find the person dead on the toilet. So there's been some famous people found dead on the toilet. I think Elvis Presley was found there too. So you're straining, you're pushing really, really hard to have a bowel movement, and it stops your heart. So anyway, but normal people who normally have everything okay with them, that doesn't happen. So I hasten to assure you, it's okay to bear down and push when you need to have a bowel movement. But just be aware that if you have a heart condition, it could stop your heart. So anyway, I thought that was an interesting thing to tell you. And I'm so glad that guy named it after himself and not after me. All right, on the outside of your lungs and on the outside of your heart, you've got a tough, fibrous sac. Now, we're just going to talk about the heart, and then later on in another chapter, when we talk about the lungs, we'll go and talk about the pleural cavity or the pleural sac. But we're going to talk about the sac around the heart. I wish that my school had offered Latin, because my son went to a school that did offer Latin, and he took it every year, and it made going through some of the medical courses so easy because he already knew what a lot of the words meant. For example, pericardium, that is around the heart. So the sac around the heart is called the pericardium, and the outer layer is fibrous, and the inner layer is actually attached to the heart. It actually touches the heart, and it's known as the epicardium. So epi means upon. So para is around, and epi is upon. So the epicardium is stuck literally to the heart. And when that guy was doing the bypass, he had to go through the pericardium and then through the epicardium to get down into the heart so that he could replace some of these blood vessels. So you've got arteries and veins, and again, they're using red for the arteries and blue for veins. And we're going to learn a little bit more in just a second about that. All right, so fibrous pericardium, and it is actually attached to the diaphragm. So there's fibers from the pericardium attached to the diaphragm so that it's held in place. And let's see, we're going to talk about the pleural later. Okay, so I think you've got all the stuff on that. The top of the heart is attached by some fibers to the sternum. So your heart is suspended between the sternum and the diaphragm. And if you were to count down your ribs, when you get down to the third rib, that's where the beginning of your heart is, right there. Or you can just come down your sternum, and it's attached to the base of the sternum. So that'll kind of help you orient where it is in your body. Now, you know that when you say the Pledge of Allegiance, you put your hand on your left side, because that's the heart is pointing over to the left. Although it seems like people don't say the Pledge of Allegiance anymore. So here's another picture, and the pericardium is actually double-walled. And this allows fluid in between the two layers. And that kind of lubricates the heart. So you know in your car, you have to put oil in your car to lubricate the pistons because they're moving up and down. And if you run out of oil, your pistons will freeze up. So you need this fluid, this serous fluid, to be secreted in between these layers to keep the heart lubricated, because it is contracting and relaxing. So it's moving. and you get friction. Anytime you have something moving, you get friction. So that lubricates the heart. Now, occasionally people will get a bacterial infection in the pericardial sac, and they say it is unbelievably painful, because if you think about it, every breath you take is like somebody has sandpaper in there and it's rubbing back and forth in those 2 layers right there. And your book had a kind of interesting thing. Maybe this will help you. It says, imagine your heart is your fist, and you take a balloon and you punch your hand down in the balloon and let the balloon conform around your hand, which is simulating your heart. And that kind of gives you the idea of what the pericardium is, with an intimate layer, epicardium, and then the pericardium, which is the outer part. So if the balloon helps you, then great. All right, now, once you get past the epicardium, which is the outside, and you've got all these fibers anchoring it, you're going to get into a muscular layer, a thick muscular layer, and we call that the myocardium. So the word myo means muscle. So anytime you see myo, you just say, oh, this is the muscle part of the heart. And lining each of the chambers of the heart, so you have a left and right atrium and a left and right ventricle. And lining the surface of that is a layer of epithelial cells, and we call it the endocardium. So it is in the inside of the heart, lining each of the chambers. So there are 3 layers once you get past the pericardial sac and get into the heart itself. You get the myocardium and then the endocardium. So those are your layers of the heart. And we're going to be learning some of the structures. They say that you've got these little things in here, these tendinous strings, to keep your heart from sticking together. So let's think about getting a wet drinking glass. So I don't know if you've ever washed dishes and you wash a glass and then you wash another glass and you put the one glass inside the other one and then you try to pull them apart and they're stuck and you can't get them apart. So if when your heart contracted, the sides touched and they stuck to each other, then your heart wouldn't be able to open back up again. So they say that the surface is rough in here to keep the heart from sticking to itself when it contracts. So it sounds as good as anything. And then you have these little muscles right here, and I'm sure that some guy named these because they named them the papillary muscles, and papilla means nipple shaped. So somebody looked at that and said, ooh, that looks like a nipple to me. So we're going to call those the papillary muscles. And you have those at the bottom of your heart, in the bottom of the ventricle. And then you have heartstrings that are attached to the papillary muscle and attached to the flaps of the heart. And here is your atrium, and here's your ventricle, and here are the flaps that separate the 2 chambers. So we're going to talk about the flaps in just a second. But these are the chorda tendineae, and this is the papillary muscle. And then there's the cusps or flaps of the valve, the heart valve. So we've done a pretty good job of this. You guys know the 3 layers of the heart wall now. And you know the 4 chambers, the left and right atrium and the left and right ventricle. And the surface features of the heart, we'll go over that some more. We're not quite done with that one. And then the 4 valves of the heart. So we talked about blood coming into the right atrium and left atrium, so you need some valves there. And then you need, let me back up a second. You have the valves, you don't need valves there. That just pours into the atria passively. So there are no valves entering through the atria. But when it goes from the atria down to the ventricles, that's where you need a valve. So that when the heart contracts, you don't want it to squirt back up in the atria. You want it to squirt out, either going to the pulmonary trunk if you're going to go on the right side, or to the aorta if you're on the left side. So you don't want it to go back up in the atria. So you're going to have some valves to keep it from going back in. All right, and then the other two valves, one of them is going to be coming out of the ventricle and going into the aorta, and coming out of the ventricle and going into the pulmonary trunk. So when it's filling up, you don't want it to be running up into the atria into the aorta or over into the pulmonary trunk. So you have four of them, and they are trying to keep the blood from back flowing. So let me show you a little video about that and see if that'll help you out. This seems to be a good time to put that in. Now I have a video that I'm going to post for the whole video. You can watch it. It's about, 4 or 5 minutes long. So it's not very long. And it goes over the anatomy of the heart. But the lady speaks in a monotone, and I found myself falling asleep after about the 3rd minute of it. But anyway, I'll post it and you guys can watch it. So here is a cool thing that they did. And I want to back this up a little bit here. Right there. Okay. And I want to play this for you.
In this anterior view, close, preventing the fluid from re-entering between the right atrium and right.
Okay, so what she's going to do is she's going to pour water into this heart. So she's opened it up, and we are looking through the atrium down into the ventricle. So up here is the atrium, down here is the ventricle, and she's just going to pour water in there. And it's going to fill up the ventricle. And as soon as the ventricle is full, the flaps are going to raise up and close so that the blood that was going down into the ventricle doesn't come back up in the atria. So this is kind of neat. I never thought about doing this, but once we started doing dissections of hearts, I had my students do this, and it's seriously cool.
Right ventricle is now visible. This is the location of the right atrioventricular or tricuspid valve. To demonstrate the action of this valve, water is poured into the atrium and allowed to enter the ventricle. When the right ventricular wall is squeezed and its internal pressure rises, an action that mimics the beginning of ventricular contraction, the water is forced superiorly, causing the valve to close, preventing the fluid from re-entering the atrium.
Okay, this is why you have that little papillary muscle, or those little papillary muscles down there, and then the heartstrings or the chorda tendineae, because this lower chamber is full of blood. So in this simulation we would use water, but it's the same principle, and it causes the valves to float upwards. So they floated upwards and they closed, and now when the heart squeezes, it should flip these things just like an umbrella. If you've ever taken an umbrella out into a high wind or driving rain and your umbrella flips inside out, except for these 3 cusps can't flip inside out because underneath they're attached to the heartstrings, the chorda tendineae. So that's kind of neat. I think that's neat.
This closure occurs when the 3 cusps of the valve come together. A similar closing action occurs in the left atrioventricular valve located between the left atrium and left ventricle, except that only 2 cusps are present in the valve instead of 3. The action of the semilunar valves differs from that of the atrioventricular valves because of the differences in their anatomical structures. To demonstrate the action of one of the semilunar valves, an incision is made in the pulmonary trunk to expose the pulmonary semilunar valve located between the trunk and the right ventricle, or pouches form this type of valve.
All right, so stop and think, what do we want to happen here? So when we filled up the ventricle through the atria, it dropped down in there, filled it up, and then the valves came up, the cusp came up, the flaps, whatever you like to call them, and it closed off that tricuspid valve so that the blood could not come back up in the atrium. Well, now we are in the ventricle and we're wanting to push the blood out through the pulmonary trunk. So how do you think these valves should work? So I've paused your video for a minute to give you a chance to stop and think. All right, which way would the blood go that you don't want it to go?
When water is poured into the pulmonary trunk, the 3 pouches of the valve fill with fluid and close off the opening into the right ventricle to prevent fluid from entering the chamber.
All right, so instead of coming up underneath and pushing the valve shut, the blood that's gone up into the pulmonary trunk will try and come back down the pulmonary trunk and re-enter the heart. And you don't want that to happen. You want it to go on, to the lungs. So these flaps, these cusps, are like, they said a shirt pocket that's filled up with water. And so as you fill this little pocket with water, it bulges out. And this little pocket with water, it bulges out. And it closes off the opening. So now I don't have to worry about the blood coming back down the pulmonary trunk and into the heart again.
The closing of the pulmonary semilunar valve occurs when the ventricle is relaxed and the ventricular pressure is less than the pressure in the pulmonary trunk. Similar actions occur when the aortic semilunar valve closes to prevent backflow of blood from the aorta into the left ventricle.
Of the 4 different valves in the heart, 3 of them have 3 cusps, and 1 of them only has 2. So it's the one in the left side of the heart. It's between the atrium and the ventricle, and it's called the mitral valve or bicuspid valve. Mitral valve or bicuspid. And you may have heard of people having a heart murmur. A lot of times some of these valves are incompetent and you can hear the blood squishing back through. So there are many different kinds of heart murmurs, but a lot of times they have to do with the valves. Sometimes they have to do with an actual hole in the heart, in the septum that divides the 2 halves. If you have that, they're probably going to have to go in and close it up, because you can't have the blood from the right side mixing with the blood from the left side. Later on, we're going to talk a little bit about the coronary arteries and name a few of them. But be aware that the coronary arteries are outside the heart, and they provide blood to the muscular layer of the heart. So that's kind of an odd concept. All right, so let's look at, this is a cadaver heart, and you see a lot of fat on the heart. And that's normal. It's not just, if you have too much fat, obviously that's not a good thing. But everyone has some fat on their heart. And if you slice it open and look on the inside, you can see the papilla, the nipple-shaped muscle. You can see the heartstrings, and you can see the valves that are attached, the cusps or the leaves or flaps of the valve. People call them different things. And the thing I want to point out to you, it doesn't matter if we slice this open and put it, you should be able to tell the left side of the heart from the right side of the heart just by looking at a cross section. And here is why. Because if you think about the left side of the heart, it's the one that's got to push the blood all the way through the aorta and all the way down to your toes. So it needs to be thicker. It needs to really be able to push the blood out through the aorta, and the aorta has to be very strong to withstand the constant pounding, pounding of the blood as it comes out of the heart and surges through the aorta. Now, the right side only has to make it over to the lungs. And if you remember, the apex of the heart is actually sticking into the lungs. It's actually compressing into the lungs. So you do not have very far to go. So you do not need a really thick muscle here to push through the pulmonary trunk. Otherwise, you'd end up just ripping your lungs to pieces with the pressure of the incoming fluid. So you can always tell the left side is much thicker, many times thicker than the right side of the heart. And then here's the septum, and there's a septum between the left and right ventricle and between the left and right atrium. Those coronary arteries that we were talking about that nourish the muscular layer of the heart, here's one of them. It is called the anterior interventricular artery, and it's running down here. And there's your ventricles. So interventricular artery is there. And if you flip the heart over, you're going to have a posterior interventricular artery. And looking right through here, you really can't see it because of the layer of fat, but that's where you're going to have arteries that are right along a little groove between the atria and the ventricles. So you've got some of the coronary arteries going in through that direction right there. Here's a slide that summarizes what we've been talking about, the 3 layers of the epicardium, the myocardium, and the endocardium. The epicardium has the outer fibrous layer that connects it to the sternum and the diaphragm. And then you have the serous. That's not serious, it's serous. And it means fluid secreting. So this is a serous membrane. And it lubricates the heart. And it says there's fat along the epicardium. And the coronary blood vessels travel through the epicardium. So that's on the outside of the heart, nourishing into the myocardium. Now the endocardium is kind of interesting. It is a lining of epithelial cells, and the lining is continuous through the chambers of the heart and continuing on through the blood vessels. And this is really important because if you have any damage to the lining of the heart or any damage to the blood vessels, any tearing, you're going to expose the collagen that underlies it. And if blood touches collagen, it starts clotting. So one of the things that there's finding on some people who have COVID and have a severe reaction to COVID is they start making blood clots. And they're trying to figure out why. Because the blood should not touch through the lining of the heart. It should not touch through the blood vessel walls. Yet somehow or another it is, but only on a handful of people. So I don't want to panic people and think, oh my gosh, if I get COVID, I'm going to have blood clots. But they are curious about why some people do get blood clots when they get COVID. So I just thought I'd point that out. And this endocardium, this epithelial tissue, also covers the valves. So those valves that we saw that were tied down with the quarter tennae. So again, you don't want any collagen showing. So you want this continuous layer of skin cells to line the inside of the blood vessels and to line the inside of the heart. So 2 things that they want you to know about the myocardium is it's muscle, and the muscle spirals around the heart so that when the muscle contracts, it produces a ringing motion. So imagine you've got a wash rag and you're twisting it to get the water out of it. So most people think of a squeezing motion, but they don't think about a wringing motion. So I'll show you that in just a second. The other thing they want to point out is there's a fibrous skeleton. So you don't have a skeleton, you don't have any bones in the heart whatsoever, but you need to have something that holds the thing together. So you've got this collagen and elastic fibers that make up kind of like a soft skeleton that holds the shape of the heart. And I don't know if you've ever eaten fried chicken. If you ever got to eat the heart of the chicken, it is chewy. It is really, really chewy. So that's what you're chewing down on the muscle, but you're also chewing down on this collagenous and elastic fibers that make up the skeleton of the heart. The other thing that this fibrous skeleton does, when we talk about how the heart works, we're going to find out it works with electricity. So your body generates electricity, which causes the heart to beat. And if you didn't have something that was an insulator, then the heart could short itself out. So the fibrous skeleton of the heart, this collagen and elastic, provides electrical insulation between the atria and the ventricles and in the septum. So you don't want the septum either shorting out. So we'll talk a little bit more about that. Seems like we're having a lot of foreshadowing. So here's the picture. So this is an actual picture. So they've torn away the fat and they've torn away the epicardium, and you can actually see the fibers and how they're in a spiral. So when they contract, you can see it's going to kind of like be they call it a vortex, and it's going to contract that way to squeeze the blood out. So I thought that was kind of interesting. And then here they've drawn in, so this is real right here. That's a real picture. But here's a cartoon picture, and they're showing you the coronary arteries. All right, the intraventricular ones, and then the ones that between the atrium and the ventricle. Right there. And see how they branch off and then dip down into the muscle to provide nutrients and to provide oxygen. So if these get blocked, that's your heart attack. You say, oh my goodness, so-and-so is having a coronary. So a lot of times it's because you block these blood vessels. And then the tissue, if you block right here, all the tissue from here on down doesn't get any blood and the muscle starts dying. And then you replace it with scar tissue. So it's important to check and see if you're having heart pains, to look and see if any of these are getting blocked off. And unfortunately in America we loved our fatty foods, and so we tend to have a lot of fat deposits that build up until you just block off your coronary arteries. So let's look at figure 19.7 out of your book. Here is, they've kind of cut the heart in a different orientation so you can kind of look inside there. Here's the septum between the right and the left ventricle, right there. And this one's more of a circular chamber, and this one's more like it's attached onto the side. And if you look at the bulge, remember the left side's so much bigger. Look at that bulge that this makes. And then you're going to have the artery running there. Okay. And let's look and see. So now is a good time to start learning the names of these vessels and the valves at the same time. So we've talked about the valves a little bit. We've talked about the vessels separately. So now let's put it all together and see if we can do this. All right, so here's the inferior vena cava, and it's bringing blood from the lower parts of the body and dumping it into the right atrium. Here's the superior vena cava, and it's bringing blood and dumping it into the aorta too, but it's bringing it in from the upper regions. So anything above your heart will be draining down into here. And this is going to lay open flaccidly, just lay open, and the fluid will run in and fill up this lower chamber. And it'll run in and fill up this lower chamber. As soon as this chamber is full, then these flaps will rise up like we saw in that video and close. So now the blood cannot flow back up and then back out these tubes, out these veins. So the vena cava is a vein, not an artery. And so they made it in blue, so you know it's a vein. All right, so that's what's going on the right side. Now let's go look over on the left side, and you're going to be bringing the blood in from the pulmonary veins. So you're going to have some from the right and some from the left because you have two lungs. And here you go. Here's the right ones over there. And they're going to be coming in. And these are the left ones over here. And they're going to be dumping into the left atria over here. And it's going to be doing the same thing. So while this is filling up over here, this one's filling up. And these are going to be flaccid. They're going to be laying, the flaps are going to be laying down. And this is going to fill up and fill up and fill up. And it's going to float these flaps up until it closes off so you don't get the blood coming back up into the atria. And now it's time for the heart to beat. It's time for that ringing vortex motion. And so the muscles will contract, and since the blood can't get back up through this flap, it's going to have to find a different way to get out. And since it can't go through this flap, it's going to have to find a different way to get out. So in the case of the right side, I need to get it over to the lungs. So I'm going to leave here, and this is the pulmonary valve right there. They're only showing you two of the three cusps, but there's three cusps of it. And you're going to go out the pulmonary trunk right here, and then you're going to switch over and split off, and this is going to go off to the left lung, and this one is going to go off to the right lung. So you have your left pulmonary artery, and over there is your right pulmonary artery going off to the lungs. Now, on the left side, when it squeezes, we really can't see that well in this particular picture, but you know that it's going to come out and it's going to go out through the aorta. So the aorta is the biggest artery in your body. And here's what it looks like there. And it arcs over the heart and then runs back down the back of you. So that's kind of surprising, kind of along your spinal column or your vertebra. So it hooks up, and here it is, up and over and runs down behind the back of your body. So that's a little bit odd. Now you have these branching off, and these are going to go up to your brain. So we'll learn about the name of those in just a minute. But I want to make sure that you guys can see inferior, superior vena cava, and then it exits through the pulmonary valve, through the pulmonary trunk, to the pulmonary arteries, to the left and right. And on the left side, it comes in through the left and right pulmonary vein, drops down, and is pushed out through the aorta. So practice that. Make sure that you've got the way that the heart beats. Two more things you need to know about the heart. in addition to the atria and the ventricles, you've got two little flaps, and they're called auricles because they're kind of ear-shaped. So there's the one, the left auricle on the left, and then there's the right auricle right there. They didn't do a really good job showing you that one. But, so you have a little extra flap, and they think that it's just to allow a little extra room for fluid. It's kind of like an overflow chamber or something. And the other word that I didn't go over with you is sulcus. So when we talk about the brain, we're going to talk about the grooves in the brain. So we're going to be talking about sulcus, but it is a groove, and you have a couple of major ones. You have an anterior interventricular sulcus, and we talked about the artery that runs through it. So there's like a little groove. It's like somebody just kind of pushed a little depression so that you have room for these arteries and veins. And then up here is the coronary sulcus, and it's the one between the ventricles and the atria. So there's that one. And then there's the coronary arteries that lay down in the coronary sulcus. So it's just kind of a groove in through there. So I want to make sure that I pointed out your little auricles and your sulci. This sulcus, that sulcus, plural is sulci. If you flip the heart over, now you can see the posterior interventricular sulcus. So we had an anterior, and now we have a posterior one. And the coronary sinus is a widening area in the coronary sulcus. So it's kind of a collecting chamber almost. So you have sinuses in your nose, you have sinuses in your brain. So a sinus is just an area that's filled with fluid. So here's your coronary sinus right there. And it lays in the coronary sulcus along with the other coronary arteries and veins. Here they've made a cut through the heart in just such a way that you can see all four of the valves. They're all three cusps, but two of them are held down by the chorda tendineae. Those are the ones between the atria and the ventricles. And then the other two that have three flaps are the ones going to the pulmonary trunk and the one going to the aorta. And they are like a pocket or a upside down umbrella, I guess, because they want the blood not to go back down. So they're going to fill up and close, where these will be pushed up like an umbrella with the wind blowing under it. And they'll try to flip upwards, but the chorda tendineae or the heartstrings will hold it and keep it from flipping inside out. So that's kind of a, maybe it will help you remember. So, and remember, the only one that's only got two flaps is the left side of the heart, and it's your mitral or bicuspid valve. But all the other three are three cusps. Here's a cool picture. I'm glad they included this for you. So you can see the papillary or the nipple-shaped muscle and the heartstrings coming off of it, but they backlit it. So it looks kind of otherworldly. So I think that's a kind of a cool picture. I like it. And this is an actual picture of your actual flaps. So this happens to be the aortic valve. And there's the three flaps that are going to fill up with fluid like we saw in the video. All right, I'm going to pause here and I will resume in our next second half of chapter 19.